Okay, so right now you got ice in there, and we're putting salt in there.
Putting salt in it, right?
And you said it's going to grab the BTUs.
It's going. First of all, that salt is going to force a phase change, and the phase change is going to be this thing melted. And I have to mix it up a little bit. So when the ice contacts the salt, it changes phases, and it's going to go from the solid to the liquid. But to do that, that's a latent heat phenomenon. The temperature doesn't change, but it requires a whole bunch of BTUs. The BTUs are going to come from everything around that ice, this container and everything else around it. It's pulling heat out of it right now. Everything has some thermal energy in it, unless it's at absolute zero and all molecular motion is stopped, which isn't the case in hardly anything. So there is some thermal energy out here that this thing is pulling in out of the metal. The metal gets so cold that it will condense the water on the outside of that, and then change that water will change phases because the metal has gotten down below the freezing point of the condensate in the air.
And it's starting to get ice on the in that
Right.
ice.
That's right.
Frost, I mean.
Hasn't yet, but it's getting there. It's definitely getting colder.
That's crazy.
But that's, this would be your skin if you did that silly salt and ice challenge on your skin.
Because
it's going to remove heat from something, and if it removes enough heat from your skin, that's going to be freezer burn.
okay,
Frostbite.
frostbite. So when you put the salt on your skin, then put the ice on top of the salt.
And that's what this does. This causes that ice to melt, and it causes it to pull BTUs from your skin.
And then that's when you get the frostbite.
That's when you get the frostbite, when it removes enough BTUs so your skin freezes.
And if we would have put cream in there in a little baggie, we'd probably have ice cream in just a few minutes, wouldn't we?
You could. We'd have salty ice cream because I put it in there with the ice, but in a regular ice maker, we'd have it separate.
But I'm talking about, like, we could have put cream in a Ziploc bag. Put
Yeah,
the
we could've
Ziploc
done that.
bag.
Yeah, and shook it up. Yeah, and it would have froze quick.
I should have brought some cream.
You can see it's starting to frost up a little bit now. It'll be completely frosted in a minute or two.
That is so neat.
And the ice on the outside of that will be harder than the ice that I put in there originally because it's...
There's no ice in the top of it. That's just the vapors.
What is that?
That's the vapors rising, isn't it?
Is it the vapors rising? Or is it heat being transferred from up here to down here?
That's right. So the heat that's being transferred from,
What kind of heat transfer is that?
trace. Is that what it's called?
Well, tracing is what goes on the outside, but we've got three kinds of heat transfer. We've got conductive, convective, and radiant. And
This is radiant.
no, radiant comes from the sun. Radiant comes from molecular
That's right.
waves. Conduction comes from heat transferred by flowing fluid. Like if I put a fan in an oven and the air was blowing around inside the oven, that would be convective heat. And conductive heat is heat that is moved by vibrational motion of molecules from one molecule to another. This molecule gets hot and it puts heat on this one and the next one. That's what happens here. This heat transferred down to this cold, and this transferred to that transferred to that. As long as there was a differential, as long as this one area was colder than the other and it was hot, then the hot is going to move toward the cold. And that's what happened. This is conductive heat. The heat conducted that way, but since the heat left here, that's why it's colder. It's not colder, it's just less hot than it was. Cold isn't a thing.
Yeah.
Some of the thermal energy has moved from there to someplace else.
All right, but now, see, the top of it's not frost like this one is. And that's because the ice is here and then it's moving up, right?
Well, the other thing is this has been cold a little bit longer, so it's developed a little more condensate on the outside of it.
So that's really kind of cool.
Physics.